Welcome to the Manitoba Ag Days podcast, where we hear from some of the most relevant, up-to-date, informational speakers in our industry. In episode 30, Dr. Rex Newkirk, Associate Professor at the University of Saskatchewan, tells his story, Fusarium Damaged Grains, Options.
Thank you very much, Stephanie and the organizing committee for having me today, and thank you guys for coming. The good news is, with the lights, it's a little bit hard to see you, so if you decide it's time for a mid-afternoon nap, unless you're a heavy snorer, we probably won't notice. What I want to do today is talk to you a little bit about what we can do when we have Fusarium. Now, you guys have dealt with it a fair bit longer than Saskatchewan has, but I remember when I first started at SIGI back in the early 2000s, and I would go from feed mill to feed mill and put on little seminars and show them what to look for in grain and what things should they watch out for and what other things are of no concern at all. And I talked about Fusarium, and they'd say, "What? Never heard of that." That quickly changed in Manitoba, and holy heavens, it sure changed in Saskatchewan. So then the next question becomes, well, if you do get this disease, and thank heavens this last year we didn't have much, but I'm not making any promises for this year, what are some of our options? And so I've done some work in the past while I was at SIGI, and I'll present some of that work, and then I've got a student that just started. Imagine this, she moved up from North Carolina to our winters to study here, so she's pretty dedicated. And so she's working on barley with some funding for Sask Barley, and then just got some money from Sask Wheat and ADF and stuff, so I'll be taking on another student to look more specifically at wheat and durum. But I want to talk to you about some of the options. And some of there's a whole bunch of companies that are selling equipment, and I encourage you to go see them, and I'll use some of their materials actually in some of my presentations, and so you've got lots of options. I guess what I want to do is give you some of my thoughts on what works, what doesn't. I think they all have their place in a way, but you have to understand everything has its weaknesses and strengths, right? And so when you go into a situation where you want to purchase something, or you're going to go into a partnership with somebody and build some sort of a system to deal with this issue, you need to know some of those weaknesses and strengths, and I'll do my best to talk about those. By the way, this is my son. He'll take any opportunity to climb on a roof, so he helped me put up the Christmas lights. And I'm thinking he has a pretty good view up there because he's 6'8", so we do know how to grow him big. But sort of looking out, so I thought that's what would be appropriate here, is we're looking out into the future, and what can we do, and what are some of the opportunities. Before I do that, I want to be a little selfish with your time and tell you a little bit about my research facility. I'm a professor at the University of Saskatchewan, and I have a very nice research facility that took many years to build, and they essentially almost pretty much completed it by the time I got there. So I got the beauty of getting to use the thing and not have to put the thing together, so that's fantastic. So we have a research facility in North Battleford. They spent $13 million on it. It's probably about a $30 million facility. Main reason being is we bought a commercial plant that wasn't very old. It went belly up when the pork industry went kaput. And so we bought it for 10 cents on the dollar. So spent a couple $1 million on a commercial mill. And then we added another $10, $11 million to it. So we can do all kinds of research on a broad spectrum of things. We're rather unique in the sense that we can do lab scale stuff. I mean, obviously at the university they can do really fine stuff. I have students that do stuff with scanning electron micrograph, and they go down to, crazy high resolutions, 5,000 times and stuff. But for this facility, for us, a lab is about 200 kilos, 200 kilo batches. And my lab scale is where the steam explosion is. So if you're interested in coming see the place, come see it. I'll blow some stuff up with you. And it literally does blow up. We're doing canola and flax and things, and we're trying to blow it up and make it more digestible. So we have lab scale with lots of all kinds of stuff that we just pull in and out. Then we have a pilot scale plant, which is basically a commercial feed mill type of scenario where it's all integrated, full throw through, but it's got extra bits and pieces to it. So we've got the ability to do things that sort of in the future people are looking at doing, or only sort of, the more advanced companies might be doing it. So we've got some opportunities there where we can do research, but still at a continuous flow, more commercially relevant. And then we can scale right up to commercial scale. And the commercial scale plant we lease to a commercial client part of the time, and then the rest of the time we occupy the thing. And there's just a few pictures of it. So, I don't know, it's a big tall building. I know there's no elevators in there, so I should be losing weight running up and down those stairs. And this is on our pilot line, so the mid-sized line, extrusion for pet foods and aquaculture and just pelleting and things like that. But we got lots of kinds of options. So that's the starting point. So that's where I'm from. You're welcome to come see it anytime, and we're always happy to do some hands-on training or whatever you need there. So now let's talk a little bit about Fusarium. I don't have to tell you this, but certainly Fusarium has been a major issue, highly dependent on when the moisture lands. I'd certainly like to see us get more Fusarium-resistant varieties, and I know those are coming along. But one of the challenges with any of these fungal diseases is their job is to overcome resistance. Right, so we'll develop resistant lines, and they'll last for a certain amount of time. They'll give us a certain level of resistance. But then eventually, the job of the Fusarium or the fungus is to figure out a way around those things. And so we have to have a backup plan. If we can't get it all with breeding, and I don't think we can make some very big strides, but we can't get it all. When we do have the issue, what do we do about it? Okay, and I just drew this little graph, some Canadian Grain Commission data from this is incidences of Fusarium in red spring wheat. And so going back into the 2000s, nobody even recognized the stuff, nobody even looked for it. This is out of the Grain Commission survey, and it's just an average of all the different zones in Saskatchewan. And then you see this up and down, up and down. And I didn't put 2017 on there, but it'd be down here this year, it'd be very, very low. I'm not gonna make a predictor on 2018. Let's hope it's down here again. Looking at that graph, that would seem unlikely, but I hope it is. So what are some of our options? What are some of the things we can do? Some of the things that I've got students that will be working on. There is a chemical methods. There's this compound that we're primarily interested in, DON or deoxynivalenol, or vomitoxin, whatever name you want to give it. You can oxidize it. It's a very stable compound. It's difficult to break down, stable to many different things. So it's not easy to do. So one of the things we'll probably be looking at is ozonation and see if we can break it down. In laboratories, they've proven they can do that. You can pump ozone in your gas and it'll oxidize the stuff and destroy the DON. But that's in a lab where it's 25 degrees and relatively high humidity and all that kind of stuff. I'm not sure it's going to do much when it's minus 30, but something we need to look at. There's other options. There's mechanical methods, and this may not be a big surprise to you, or maybe it will, but there are ways of knocking some of that Fusarium off. It is essentially a mold-type product, and so it adheres to the outside of the seed. And so basically, by bumping the seed around, sort of broad terms, I guess, but by bumping it around, you can essentially knock some of that free. And then by using pneumatic movement, you can knock off a fair bit of the spores that contain the toxin. Okay. There's also mechanical things we can do where we can take out the really infected seeds, and I'll show you some examples of that. So those really light tombstone kernels, sure, we can take those out by gravity. And then if we can't do it with mechanical and more simple methods, then we have to start going into ways that we can identify each individual seed and try to take those out. Because one of the things about Fusarium is as it moves up the seed, or up the stalk of the heads, that disease moves. So you have a wide gradient within your field, within your bin, within a handful of grain as to how many of them have this toxin and how many don't. Okay? So that's a challenge from an analysis perspective, but it's an opportunity for you. Because it means if some of them contain most of the toxin and some of them don't contain very much or none, hopefully, then we should hopefully be able to separate those two things. Okay? And so that's what I'm going to spend a fair bit of time on. The first thing I really need to drive home, though, is before you do anything with any of this and before you take any of these measures, you need to know what you've got. And I think in Manitoba you're a little better at this than we are in Saskatchewan, and certainly better than Alberta because you've got more experience with it. But, so I work in the feed industry now again. And so I know that producers will phone up, the feed mills and say, hey, I've got this wheat, it's 1% fuzz, will you take it? And they'll say, I don't care if it's 1% fuzz. Fuzz means nothing to me. I need to know what the DON concentration is. Let's get a sample in here, let's measure the actual toxin, okay? So the official grading method through the Grain Commission is to do a visual assessment for Fusarium, and it's looking for those signs of disease. And unfortunately, I'm too blind to really do it very well. You've got to have a pretty good set of eyes and magnification to see it, but the experienced inspectors can do it for sure. The problem is that just because you can't see it doesn't mean that the toxin's not there. And that's the biggest problem for us. And from a livestock perspective, certainly DAWN is very critical to us. It's actually the toxin. We don't care about the rest of the aspects of Fusarium. All we care about is the toxin, okay? And the same is becoming true as well in the milling industry. It used to be we sold all our grain just based on the Grain Commission specs. But as the Fusarium issue became larger, more and more of the customers are demanding that they know what the DAWN concentration is, because there's very stringent requirements. I'll show you some of those in Europe. And many of our customers that may not have those same requirements from a government perspective are starting to implement those within their country as a company to reduce liabilities. And so there's very tight regulations on the Fusarium. But it's not so much on the fuzz content or the FDK, it's on the DAWN or the vomitoxin. Sorry, there's so many different names for this. I'll just call it DAWN from now on if that's okay with you. Okay? And traditionally there was a correlation between the fuzz and the DAWN concentration, but that correlation would be pretty tenuous. And especially after we start doing things to clean it out, and you start taking out those really obvious ones we can see, right? You'll still have some DAWN in there, but it looks like the grain is really clean. And so we have to be careful on that. So I mean, we need to do whatever we can to recover as much grain as we can, absolutely. But you have to remember, just because you can't see it doesn't mean the toxin's not there, okay? So I just thought it really important to point that out. The other thing you need to know is because it varies so much across the field, that you need to make sure you get a good sample. And I'm sure you've had lots of people tell you this, but don't just grab a scoop, open up the bins, that little spot there where there's some, grab that and say, this is representative of that bin, or don't just take one sample out of the truck as you're unloading it into the auger and expect that to represent. Because it really moves all over the place. And so you've got to make sure you get lots of good samples, pool those, subdivide them, and this is the problem for us in research. Because, whenever we set up an experiment, we want 1 ppm DAWN, 2 ppm DAWN, 4 ppm DAWN in the diet, so on, right? So we take a sample, we analyze it, we get, 3 or 4 totes of grain, stick a probe in there, analyze it, and it comes out at 8 ppm. So we say, okay, we'll put in 1/8, 2/8, half, to hit those targets, make the diets, and they'll come out at totally different numbers. It's because it just varies so much. So that's a major challenge for you, especially if you're going to look at dilution as a solution, pollution to pollution kind of affair, where you're just trying to blend it off. You have to be really careful because it varies so much. Okay, I don't think a lot of producers have DAWN testing kits, but I'm starting to wonder, because of the incidence of this, maybe it would make sense. They're not that expensive, they're not that hard to use, and you're spending all kinds of money to grow this crop. You're putting a fair bit at risk whenever you don't exactly know the DAWN concentration and you're taking to elevators and stuff. It'd be much better if you knew what you've got, so you could manage your inventory, especially if you're going to do any blending or anything. And so for us, what we do is obviously get a good sample, and there's lots of different rules around that as to how you might want to do that. But basically, make sure you're certain that it's representative, that you're not missing some major pockets. And so what we do is we take multiple samples, subdivide them, divide them, and divide them, right? So take a bunch of samples, mix them all up, take 2 pails, dump them over the pails, take 2 pails, dump them over the pails until you get down to a small quantity, and just keep mixing them up, okay? So a lot of the variability in assays, and I don't know, have any of you ever taken your samples to 3 or 4 different elevators and got 3 or 4 different numbers or 5 different numbers? Is anybody willing to admit to that? Nobody's had that happen. Wow, I'm shocked. Okay, there's one person that's willing to admit that's happened. Well, the assay itself is actually fairly repeatable. What's not repeatable is, like I say, you take what you think is a 1-ton load, and you take a sample, you take 5 different buckets and you take them to the elevators. Each one of those buckets will have a different number, unfortunately. So that blending and variability. So what we do is we take our good representative sample, mix it up, and then the assays that most people are using is called an ELISA assay. It's basically an antibody assay, where there's antibodies that basically bind the toxin to a strip, and you can measure it with an enzyme on there. And it's basically like a pregnancy test, right? You see 2 lines, you're pregnant. You see 1 line, you're not. Maybe you guys haven't done that in a while. But basically, that's essentially what it is. The trick is, though, is the actual toxin that's in there is competing with toxin that's in there that you add with an enzyme on it for those binding sites. So what happens is as you have more and more dawn in your sample, it outcompetes the other dawn, so therefore you don't have color. So what happens is the color actually goes down as you have higher dawn. So that second line actually disappears. Okay? So what that means is that once you get down to no color, guess what? You don't have any idea what you've got. You just know you're over a certain amount. So say our test goes up to 5 ppm. If I'm going to have more than 5 ppm, I need to dilute it, more and more because, it can only go so high unless you dilute it extra. So just be careful in that. If you send out samples and they all come back at 5 ppm and you say, hey, I'm 5 ppm gone, but if it wasn't diluted, you might have 10, you might have 15, you might have 12, who knows what you got, okay? So it's just something to be aware of. And then we just have this little reader that measures the intensity of the color. So I'll give you a couple pictures of that. So certainly you can send them out, Intertech, SGS, Prairie Diagnostics, other people will certainly do them for you, and they're quite reasonable in their cost, and they turn them around quite quickly. But like I say, you can buy the kit. I bought the system for my student. I think I paid about $3,500 for all the stuff. And I bought a little $100 scale to weigh the stuff. And I already had pipettes, but I guess if you didn't have a pipette, you could spend a couple $100 more on a pipette. But we did have to buy a grinder in addition to that. And the grinding is really important. You need to get a good grind on it. The Grain Commission, Prairie Diagnostics, they tend to use very, very expensive laboratory grinders, and you'll spend thousands and thousands of dollars. What we found is that, and many in the industry use this Bun coffee grinder used at a very fine grind. Gives us a very nice grind, very representative of those expensive labs. So I think that was about $1,600, I think I paid, something like that. And then they actually have to buy the little strips and the supplies, and they're about $15 a sample or so. But if you follow the instructions completely, you can get very repeatable results. Certainly, and if you're not sure how to do it, I'll certainly set you with my students and they can teach you. But just remember that range. If you think you've got something really nasty, you better dilute it. Otherwise, you're going to be doing it over and over again because you might go out of range pretty quick. And so what she does is she grinds it, she weighs some material up, adds water to it, like she puts 5 grams in there and adds 10 milliliters of water, whatever it is, mixes it up, and then she puts it in, she shakes it all up on a little, that comes with the kit, a little vibrator thing that mixes it up for a certain amount of time, put it on these little filter papers, you get a few drops out, and those drops are put in your little strip, and it develops the color after 30 seconds or whatever it is, puts it in this little reader, there's a little printer on there, and it prints out your value. Okay? So it is quite doable, and I think given your investment and the risk associated with it, it might not be a bad idea. We ended up buying ours from a local supplier because then we just go get the kits and stuff whenever we want, but there's many different sources of them. Okay? So let's talk about some of the options. What are some of the options for your Fusarium? Well, I suppose the most common would be dilution is a solution to pollution, right? Blend it off. And that can work on years when you have very little Fusarium and you're really certain of what you're doing. But there's risks associated with that. I don't want to ever see you in a situation where you're going based on fuzz values. You decide, well, I can blend it off, and then you end up ruining everything you've got. You had a bunch of good grain, and you ruined it to get rid of some poor grain. So you really need to know what you're getting into there. Just be super careful in that. Obviously, in years like last year in Saskatchewan, there wasn't enough good grain to try to blend off the bad grain. So that posed a significant challenge. I guess this year will be less of an issue. The other option for us is to sell to the industry that will take it. And for us, in the livestock industry, that's beef. Beef really sensitive. CFI says no more than 10 parts per million in the diet, but I know there's lots of people that feed a lot more than that, and as long as they're not pregnant stock, like I'm talking feedlots kind of thing here, they can get away with quite high levels. They're just not very sensitive. The rumen tends to break it down. But that's a long ways away from you. There's not a lot of feedlots here. So you're shipping to Alberta. What's your cost of shipping from here to Alberta? How much does it cost you to take your B train to Lethbridge per ton? It's not cheap. So that's taking away a lot of the value from that material. Swine are the most sensitive, so you can sell it to the swine industry around here, but they're just as sensitive as the food industry. We typically try to stay under 1 ppm in the diet. And if grain's making up 50, 60, 70% of the diet, we really don't have a lot of room to go above maybe 1.5, maybe 1 3/4 ppm DON. Well, again, that's basically where the milling industry is. So you've got lots of swine here, but challenges, chickens are sort of in between. We can feed more to chickens, but not a lot of chickens available to you. So that's a challenge. And you have to remember the feed mills that are buying this stuff, unless they're specific for a species, which most are not, they have to think about, they have one bin for their wheat, right? And so if they're going to be selling stuff to pigs, it doesn't matter if someone's going to beef and chickens. They got to meet the beef one. So they're going to have their standards pretty low. If they're only primarily feeding chickens, well, then they can buy a higher DON stuff. And that's why you'll see different feed mills having different maxims on it, okay? So those are some options. Or what we can do is we can go through a process and try to take out those grains that are contributing the most to the toxin and find homes for the more intensely material, or more higher level material, okay? And that includes cleaning it. So for the most infected seeds, and you've seen them, those tombstone kernels are light and fluffy. Those ones are pretty obvious, and there's lots of cleaning ways you can take those out, whether it be by size, density, you can use an air separator. You got lots of options to take those out. So that'll actually take it down the DON quite a ways, but it's not going to get you anywhere near to the level you need to get maximum value out of it. But it's a start. And so that's a very good start. But then we can start looking at what kind of options do we have to take out and to specifically pick up those ones that have the disease. And I mean, for my student, I've given her the challenge. I know I'm in the livestock industry, but her job is to look at all the different options and come up with what option gives the greatest return to the farmer. That is, we can clean up to right down to 0 DON, say, but you're going to have to throw away 99% of your grain. Well, that does nobody any good, right? But if we could recover 50% for malt, right, and 30% for chickens, and only have to ship off, what am I left here for percentage? I didn't add it up in my head, sorry, I got talking. The last little bit, send that to Lethbridge, right? Or if it's really heavily intense, we'll talk about other options for that. So that's our goal, I think, is to find that optimal value. So as I mentioned, those heavily diseased kernels, they're pretty obvious, and you can take those out. The problem with that approach is it only takes out the ones that are visual, okay? And like I say, I'm somewhat blind, it seems. And so when I look at grain and I see wheat, and if I'm looking at wheat that's got low hard vitreous kernel content, so it's not very vitreous, some of those sort of flowery looking seeds, the chalky endosperm, they start looking a little bit like the tombstone kernels if I'm not looking very close. Right, so sometimes you can confuse it when you look at it visually. But we have options to do that, and I'll talk about those. So there's lots of companies that do the sorting based on the visual characteristics of the seed, okay? And that can be shape, that can be color, most often color. And actually, you don't even have to go to normal color like we have. A grayscale actually can work pretty well. And so that technology exists out there in fairly large scale. Pretty accessible. I know certainly people have been using a lot of it for pulses for many years. They've been using it for ergot for a long time, and we see some good results. And I've got some presentation materials, just to be clear with you, from some of the companies that distributed the stuff. It's not that I'm trying to promote them. I'm lazy. I got material from them, and it was really handy. But I'll try to be clear on the slides to show which ones are theirs and which ones are my stuff. Okay. So if we start with the easiest, cheapest process, there's, I think, 4 or 5 different companies that sell these ones here. I got these pictures of Flamin. But basically, you got this little machine that basically is a wind tunnel. The grain goes into it, the wind blows through the grain, the light fluffy things, they go out in these later bins out here, and the stuff that's higher density goes out in the first ones. And so it'll certainly clean off the chaff, it'll clean off some of the materials that might be high in DON, certainly the most infected seeds, but they'll only get sort of the surface of them. But it's a starting point. And so there's been quite a few people, I think there's been some people buying these, and hopefully they go into it with their eyes wide open, because it's only going to get you so far. You have to recognize everything has its limitations, and unfortunately sometimes the cheapest things and the simplest things are the ones that have some of the more limitations. But they're certainly worth a try. And so we're starting to see these in there, and that'll get rid of some of that light, fluffy stuff. This one's a little interesting to me, and I came across this when I was working in the flour milling industry. In the flour milling industry, what they do is, in order to enhance water absorption and so on during the tempering process, they put their grain through something called a scourer. And it's not actually trying to take anything off the seed or anything. All it is beating the hell out of that seed, right? So it's basically a rotor with all these little fingers. I got some pictures showing up. And it's got a heavy screen on the outside. It's pretty abrasive. And these seeds just sort of bump about. And it's not trying to peel the edges off, but basically that abrasion and that knocking about can knock off some of that Fusarium. And they see pretty significant reductions in their Fusarium in the flour mill. And so that helps them meet their targets for the food market. So I think the same kind of thing could be applied on farm. Have any of you tried putting your Fusarium-infected grain through a grain vac a few times and see if you get dawn down? Has anybody tried that? Anybody willing to admit? Yeah. Did it work? Good. Yeah. And that's essentially what you're doing here, right? Is you're moving around, the air takes off the dawn, and you can get some pretty significant improvements. I think in the flour mill you're looking at about a 70% reduction, so that's pretty good. So that's one of the things we're interested in. This is stuff from Nextseed, they gave it to me, but they took some stuff that was 1.6 ppm. This is barley, and they reduced it to 0.7 by putting it through what they call a de-honor, which basically is a bunch of arms that beat the bran up, or beat the material up. I suppose that might not be great for malt, and you get peeling and stuff like that. But I think that's something we could certainly consider. Not very expensive, and quite manageable. So I think that's an option for us. And this is the example. The other one was barley. This is wheat. So this is the little bar in there. It's got two different kinds of things on the rotor, but basically it's moving that grain around pretty aggressively. Basically bumping onto itself for the most part. Oh, darn it. Did I screw it up? There, does that still work? No? Oh. There you go. Thank you. And so basically within this screen, the grain's moving around. It's really more about moving the grain against itself than it is about actually beating it with any mechanical methods. It's really about the grain bumping into itself. Because as you know, most of your Fusarium sits in that little crease in your grain, and so somehow you got to get some bumping action that's going to get into those creases. And so that's sort of the idea. So you put it through a system like that, and you can reduce the dawn concentration. Again, another option for us. Wow, these pictures are not showing up very well. I apologize for that. You can't see anything in there, at least I can't. Well, you guys all know gravity separators. So you can separate the grain based on gravity. Again, take with those lights, and your dense material goes off to one side, your lights off to the other, and you can separate them based on your angle and the movement. So gravity tables, we'll take out those light materials, maybe give a little better separation than we get with the air. But certainly an option for you. Oh, wow. These pictures are not turning very well. Is it possible to turn off a light in the front? You guys promise not to go to sleep on me? It won't help? Okay. Oh, okay, use your imagination with me today. Because unfortunately the diagram's in white with little tiny black lines, and those black lines aren't showing up. But essentially what happens in a color sorter is the grain's coming in, it finds its way down a channel, gets everything sort of lined up in single order, if you will, down these channels, and then it flows over like a waterfall. And this grain, as it's going over, this camera's looking at it in multiple directions. And there's different kinds of cameras. And you train those cameras to say, anything that looks weird, kick it out of there. And you know from the point of the camera to the point where the air nozzle is, there's a certain distance, and you calibrate it for that. And so essentially you train it, so if it sees a kernel like this, which is Fusarium infected, then kick those out, but leave all these ones. These are the good ones, okay? And so it'll look for those cameras. And you can look under visible light, or you can look under that gray. And actually sometimes, like say, the black and gray tends to, the gray levels seem to work as well, if not better, than just being what they call RJB, okay? And this is just an example of how you can enhance those cameras. There's different ways you can look at that grain, okay? And so there's the normal camera where we look at it with our eyes, and so this stuff's flowing by, say it's flowing by at 100 bushels an hour, right? It's going by there pretty quick, but those cameras are pretty quick. And it's got to find the Fusarium-infected grain in there. Well, there's one right there, and there's some others in there. There's a couple over here, but you can't see them in this one. So if you train it well, you can get, like say, the worst of them. And so that'll start, again, taking off that top edge. However, if you, instead of looking at it with visible light, we look at it with near-infrared light, which is a spectrum we can't see. It's one we typically use for chemical analysis. It gives you a very different look at the grain, and so now you start seeing them popping out, the ones that are infected by Fusarium, and then it'll pop those out. But that camera costs you quite a bit more than the RGB, so you're going to spend a fair bit more on it. And so that's an option for you. And then if you really want to get a good camera, there's something called in-gas, which is a type of NIR, but it's pretty sophisticated. And again, it just makes that resolution much higher, so it makes them pop much more. So you'll, again, pay a fair bit more for the in-gas, and there's a few companies now that put the in-gas cameras in, but they really make those pop out. So if they have significant signs of Fusarium, you can certainly take those out using those technologies. One of the challenges with them is as that stream's going by, you know, as that air nozzle goes across, you're going to catch a few good ones with the bad ones. So what you do is then you have it set up so it recycles through and resorts some of it to take out some of the good grain from the worst of it. Okay? So you don't lose too much, because that's just one of the, you know, if you run it really slow and it just dribbles by there, you'll have no problem with crossing out. But if you want to run it at full capacity, you'll probably have to use a channel or two to resort. Okay? Yeah, this isn't working very well. So basically, this is, again, some stuff from Nextseed, where they just did an RGB camera, just a regular color sorter. And so they started with 3.1 ppm Dawn. The stuff that was coming out of there that it said was good was 1.4. The stuff that went back through for resort, after it had been resorted, that was 7.2. And then your final reject stuff was 15 parts per million Dawn. Okay? If we look at fuzz, it only had 2% fuzz. The accepted stuff was 0.5, so it almost looks like there's nothing there, but there was still some Dawn. So again, Dawn is much more important than Fusarium. And so now you could sell 84% to your intended market, 13% to your local beef market, or to beef producers or whatever, and then you've got 4% that, well, you'll have to find another home for it. And I got an idea for you coming up at the end of this slide. You'll think I'm a little crazy, but I'll throw it up there anyway. Another technology we've been working on is something called a bow mill. And you guys all know seed singulators, right? You know how to individually put your seeds down and they go in your seeders and all that kind of stuff, right? You can separate the seeds individually. Well, this here's a seed singulator that basically uses near-infrared transmittance. So when you take your samples to the elevator and you get a protein on it, they put in a machine and it gives you a protein number. Has any of you ever wondered how that happens? And sometimes it seems like a magical science that may not be precise, but actually it's very precise. What it's doing is it's shining this light that we can't see, called near-infrared light, into the seed, and that light interacts with the molecules, and the ones that it interacts with get absorbed. And the ones that don't get absorbed keep going through. Or, we can do all on the reflection side, where the stuff that doesn't get absorbed gets reflected. And by developing what we call the calibration, we can measure specific chemical compounds. So you can measure moisture, you can measure protein, you can measure fat, you can measure all kinds of things based on these calibrations. Okay? Well, what this machine does is it uses that type of technology, but on every individual seed. And this is the lab version. I'll show you the larger version in a minute. So what it does is the grain goes in there, it singulates them, so it puts them in the tiny little pockets, and as the thing goes around, there's a light, this is like, say, the lab version. There's a light source here that puts in near-infrared light on top of the seed. Through the little channel, there's a spot for the seed to sit, and there's a hole that goes all the way through, but the seed doesn't fall through. And the light shines through that little hole. On the back side, there's a little detector. This thing's turning fairly quickly. And from here to here, it has to decide good, bad, or indifferent. And whenever we start running this stuff, what we do is we run some through and we say, okay, using the calibration, so we're using a high HVK calibration for Fusarium that we helped them to develop. And we say, tell us what's the distribution of the seed. The problem with this technology is that you can't measure Dawn by NIR, not at the levels we have. It's too small. But what we can measure is the changes to the seed because it's got the disease that's causing it to produce the Dawn. Okay, so we're not actually measuring the Dawn. We're just measuring what are the chances the seed likely contains Dawn because of it's been diseased. Does that make sense? And so what this spectrum does here is it puts it into, this is the least likely material to have any dawn. It has no signs of disease. This stuff here is very likely. And you get a distribution curve like that. And then what we can do is we can draw our little lines and we say, well, I've got 2 ppm dawn. So if I take out maybe 4%, so let's move this line back to take out 4% of the grain. We'll take out 4% of the worst, or 5% or 10% to get that dawn level down to where we think we want to be. And then we can put it into different fractions. So this fraction goes into one pipe, this one goes in another. And what happens is a little air nozzle below there. And if it wants to go in, if this fraction is going to go in pipe 1, there's a little puff of air and it goes into the thing. Okay? You probably see our little plastic or brown paper bag there too. That's rejects. And that's one of the problems with this technology, is if that seed goes through and it doesn't recognize it, it's nowhere near to what the computer thinks it should be, it's going to kick it into a reject pile. And there's many reasons for that. It could be an ergot, it could be a rock, it could be a canola seed, but it could also be a seed that was maybe on its angle and light shot around it. And it says, wait a minute, it didn't absorb anything. So it'll reject some good seeds. Okay? And so what Taryn is doing is she's looking at this process, looking at if we pre-clean it and then put it through this process, if we use different calibrations, how are ways that we can get it, and then what are those cutoffs for different levels to try to figure out what's our maximum going to be. Okay? So just a little example of the near-infrared transmittance. Bow Mill gave this to me, so again, I'll give them some credit on that. This is their example of it. This is an X-ray, not near-infrared, but I guess it gives you an idea. If you look at this person's hand, it doesn't look like anything's wrong, right? I think if you looked at the outside of my head right now, you'd say nothing's wrong. But if you actually looked inside there, you'd know it's all messed up. Well, that's essentially what's happening here, is the X-rays are going through that hand. On the other side, it's taking a recording, and you can see that clearly there's a finger broken. So that's what near-infrared transmittance does for you, is it's shining through the product and looking at it. So most NIRs that we use, for example, when you do protein ions, we call reflectance. So you shine the light off of it, what's not absorbed gets reflected out, and you measure it. In transmittance, what it does is it shines through the seed, measures what's on the other side. So that's a benefit, but it's also a challenge, because it means that you need to make sure that the light is actually hitting that seed and going through the seed. Like say if it goes around it, you're out of luck, right? Or if it's a really skinny one and it doesn't have much chance to absorb light, some of those kind of things, okay? This is the larger bow mill. At our plant, we put in one of the first they put in installed in North America. I think it was number 2 in the world, actually. So it was a very early one. Now they've produced a number and installed them, but we were pretty early out of the game. But from the outside, it looks like a square box. Grain goes in here, grain comes out there, and you basically, on our little lab line, we can go to six segments, and this one here goes into 3, which is, say, good, bad, rejects. So you basically have little plastic pipes that take them off to the bins below. Okay? So we have some units installed here in Manitoba. There's some installed in Saskatchewan as well. Some producers have started to buy them. They're rather expensive, but they've made that investment. And so this one here is one that was installed by Flamans in southern Saskatchewan. And so he's basically got the grain going into the unit, and then it's coming out of the bottom through the floor into the bins below. And so here's another install where you can see the back of the unit. Some of it's still open. I guess they're still installing it. But you see basically the 3 lines, and they've got some plastic pipes that divert off to the different units. The way it works inside, though, is you've got this big rotating drum with a whole bunch of slots inside of it. Unfortunately, you can't see it in the picture there. But as that drum goes around, the grain gets caught in those little slots, those little pockets. And it's turning fast enough, they stay in those pockets from centrifugal force, okay? And as they go around, then a detector is shone, or light is inside the unit, shines through to the other side of the detectors. It's got to split a fraction of a millisecond to make its mind up as a good, bad, or indifferent based on that way we set the little curve. And then it uses some little air pockets on the outside to put it in one of those 3 bins. And so inside, this is what it looks like. You have these little channels with little holes through it, okay? And this is your drum. This is one of the shortfalls of this unit, is that the grain has to fit in those slots if it's going to work. Am I out of time? 5 minutes. Oh, crap. Okay. I'll go faster. Anyway, you have to make sure those grain will fit in those slots. So I think if you're going to make this work, you really need to pre-clean this stuff. If you've got a widely variable size and you've got a bunch of chaff and stuff, you're not using it to its capacity. So it's important that those seeds fit in there and that they cover that hole. Okay? And there's our unit at our plant. And this is what it looks like inside. There's little steel dams that basically have the air nozzles on top, blow the grain out. If it's supposed to go in this bin, then it blows on top of that when it comes out here. It's supposed to go in that bin or whatever, right? This is the reject pile. I think, Okay, so just a couple of examples of stuff we did while I was still at SIGI is in 2014 we had the major issue and we just got this unit. We went out and got a bunch of material with varying levels of fuzz. So we're still using fuzz at that point, sorry. But I'll give you the dawn levels. And so we wanted to know how much can we clean up out of that? What's the potential to recover that? This was a winter wheat year. That was a really bad one. Durum was also a major issue, certainly a huge issue for us in Saskatchewan last year ago. And so we took some stuff that was pretty nasty. I mean, you get to 18%. That's pretty much burnable quantity, right? That's you wouldn't think you'd be able to get much of that. But we thought let's push the limits. If you look at the dawn levels, this is what you can sell into Europe: 1.25 ppm dawn in the grain for wheat, and then durum's 1.75. So pretty tight specs. What we did is we took the 6.6% durum, sorted it. This is the fuzz. This is the dawn. We're able to get that fuzz down quite nicely, so taking 10% out plus the rejects, you're able to get down to 0.6 fuzz, but you still had 2.6 dawn. Right? So again, dawn is your key thing. So we had to take out quite a bit before we got down to that less than 1.75. Okay? So we're down to 30% out in this case. But if we looked at the prices that were being offered at the time, the original material pretty much had almost no value. But by the time we sorted out, we found the 10% level and diverting it off to the different streams, that our greatest return was on that one. We also did the stuff that was extremely bad, 18%, that's terrible, 20 ppm dawn. And, but again, we were able to get that fuzz down, but trying to get those dawns down to those low levels, this is all feedable, no problem. That's not feedable, but we're not low enough to get it into the food market on that side, okay? And I just got a whole bunch more examples of how that works. So I'm just going to fly through them for time. So anyway, so we're working on this. We're trying to optimize it. I'd like to encourage you, if you're interested in this area, contact me. We would certainly like your samples. Because we have a small unit now, we don't have to have the 5-ton lots like we did before. Bring in a pail full, and Taryn will sort it with you. She'll measure the dawn, and we can look at, and she'll use that as part of her studies. She wants to have a broad range of samples. And so I'm always looking for samples. We're also looking for big samples as well. And so she's trying to optimize that. With this little unit, this is barley. Barley's harder. So many of those examples I gave you really apply to wheat. Not so many of them for barley, because that hull confuses everything. You can't really see the dawn in there, right? And you get a lot more thins in barley than because of Fusarium. So it's much tougher. So she's working on barley and trying to get as much malt out of it. Our target is, if we can get less than 1 ppm dawn out of this material, so she started with some stuff here that's 3.5 ppm dawn or whatever it is. And what she did is she looked at it, if we didn't clean it and we did clean it, how it would improve things. And we found that if we cleaned the material, we were able to be much more effective. And these fractions are 16, 16, 16, 16, equal 16% fractions. So basically you got 1, 2, 3, 4 fractions if you cleaned it. 4 times 16, 64% of the grain you could recover. That would be under 1 ppm, that then you have a place to sell it. Okay, and then you've got this other fractions that we would be able to use in livestock, no problem. And even this one here, if we cleaned it out first, now the cleaning is going to be high in dawn. We cleaned it out first. This is still going to all make it its way into the poultry industry, say. So that's what she's looking at. So anyway, I guess my recommendations is we have lots of options. Be careful if somebody says, this really cheap piece of equipment will fix all that ails you, because that's not true. There's options that'll work. They have their limitations, and just be aware of those. If you can test it for yourself, go in, use their equipment, and find out. Obviously, the lowest cost, simplest method is desirable, but it's usually less specifically in the case of barley. The gravity air method will get rid of some of those tombstone kernels. The physical methods will get rid of those highly infected ones. The optical sorters will get some of the ones that are a little harder to see, but the NIR option will let us see some of the ones that we can't see visually. Okay? And so we need to find the optimal value. What do we do with the really, really ugly stuff? Well, that's still a concern. And we've got research going on at the university where Fiona, what she's been doing is feeding mealworms. Because they can eat this stuff, they grow well, they don't die, and they convert it into very high protein, high fat material that has a lot of value. by feeding to mealworms. Now, I'm not going to eat the mealworms, but boy, I tell you, my chickens sure love them. So that's her next stage of the project. Is she's found there's no toxins in those worms. Now she's going to be feeding the chickens. So there are some options and I'd just like to thank the people that fund my research. So there's a bunch of people that fund the different research I do. There's my contact information, and I'm out of time. I'd love to have a question if I could. Any questions?
We would have time for a question if there is one from the crowd. Seeing no questions, I'd like to take the opportunity to thank you for coming to Brandon, Manitoba in January. I just looked and it's supposedly 3 degrees outside.
Oh my gosh.
That's above the zero.
I brought the warmth.
Well, thank you very much. So if we could just show our appreciation to Dr. Newkirk for joining us.
Thanks for tuning in to the Manitoba Ag Days podcast. We'll see you next year from January 22nd to 24th, 2019.